Technip leads the industry in construction of SPAR platforms with 14 completed SPARs currently in operation around the world. We have more direct experience and expertise than any other company. The Perdido SPAR, completed in 2008, is nearly as tall as the Eiffel Tower and weighs twice as much. Building a SPAR is a massive undertaking, and there's only one company with the knowledge and resources to do it right: Technip. The fabrication process starts in the workshop, where major components are constructed in sections. Truss spars are divided into three major components: the hard tank, the truss, and the soft tank. Hard tank fabrication begins with the preparation of the steel materials, a process that involves blasting and priming. Moving through the workshop, steel plates are cut to the required forms. The plate edges are then beveled by machining, not flame cutting, to ensure high dimensional accuracy and a quality bevel for welding. Heavy-duty panel line is used for fabrication welds of the shell panels, deck panels, and center well and radial bulkheads. After the panel line phase, shell panels are sent to the bending jig, where they are bent to the design curvature of the spar and then fitted with ring girders and deck sections. Depending on its overall size, the hard tank includes between 5 and 9 ring sections. Inside the workshop, each ring is first assembled in 16th, 12th, 8th, or quarter sections. These are then combined into upper and lower half sections. The half sections are transported out of the workshop to assembling rails in the yard, where they are mated into whole ring sections. The upper half is lifted hydraulically by crane towers, while the lower half is positioned beneath it. The towers then lower the upper section onto the lower section so they can be positioned and welded together. This process is repeated for the other ring sections. One by one, these finished ring sections are welded together on the rails to form the completed hard tank. Truss fabrication also begins by blasting and priming the steel. The prepared steel plates are then rolled into tubular sections, which are welded together to form the individual truss members. The heave plates are typically fabricated in two halves. The steel is prepared and fitted with stiffeners and girders. Heave plate half sections encompass the truss nodes, as well as riser and umbilical guides. The half sections are transported to the rails. The lower heave plate section is raised into place. Then the upper heave plate section is lifted vertically and welded onto the lower section. Once the heave plate is in place on the rails, the X-braces are lifted into place between the truss legs. This process is repeated for each truss bay. The last major component is the soft tank. Again, the steel is prepared and panels are fabricated on the panel line. The steel panels are then welded into soft tank subsections. All subsections are completed in the workshop and then transported one by one to the rails, where they are assembled into the finished soft tank. Special structures like the hard tank to topside connections, hard tank to truss connections, soft tank to truss connections, chain jack and fair lead foundations, and SCR porches are all fabricated as separate components, then integrated into the hull sections in the workshop. Strakes are fabricated into panel sections in the workshop. They are installed either on the half-ring sections inside the workshop or on the completed hull at the rails. All strake panels are welded directly to the spar, except for those on the belly side. If required, belly strakes can be installed at a later phase in execution, after float-off, when the hull can be easily rotated. Final outfitting generally occurs while the three main components are being welded together on the rails. Some of this outfitting is completed in the workshops, such as piping in the ring sections, anode fit-up, and top of spar components. The rest is completed at the rails, including caisson installation, SCR hard pipes, pull tubes, and chain jack and fair lead installations. Many installation aids are also attached to the hull, either at the workshop or at the rails. Top of spar installation aids include the tow platform, sheaves, temporary piping, and winch foundations. Mooring installation aids include messenger wires, and SCR installation aids include messenger wires, sheaves, and roller boxes. Loadout is the process of loading the finished hull onto a transportation vessel using rollers and a hydraulic jack system. First, the transportation vessel is moored to the bulkhead. Temporary rails are laid on the ship. The spar hull is hydraulically jacked into position along the rails. Then the load is transferred from the rails to the cribbing. Sea fastening brackets are put into place around the hull, and any remaining loose items are loaded onto the main deck. After final preparations, the vessel leaves the fabrication yard and sails to the final outfitting yard. More than any other company, Technip has the experience and expertise to design and build your spars successfully and safely, on time and on budget.